everyone, I'm Rashmi Nagpal. I'm a machine learning engineer at PathStack and also a researcher at MIT CSAIL. So today I'm going to present on the topic XAI in WordPress security, understanding the why behind AI-driven decisions. So without any further ado, let's begin. Next slide. So this clicker will go on the next, this one. Okay, sorry about the technical issues in the start. So we know that approximately 45% of websites, they are running on the WordPress, be it blogs, personal websites, and so on and so forth. So it implies there is a big onus on the WordPress ecosystem to make sure it's secure. Next one. It doesn't move, the next one. Okay. There is a recent article released by PathStack, which is a state of WordPress security, and it shows that approximately 96% of the vulnerabilities were released and were found in the plugins. Because there are three major components in the WordPress, which is the core and the themes and the plugins. As you can see over here, approximately 96% of the vulnerabilities were found in the plugins. And XSS, which is also one of the highest, or I would say a popular vulnerability identified in those plugins, along with broken access control and CSRF as well, and cross-site scripting as well. Okay, so now this is where the core of my talk starts. First, I'll explain what is AI, and then I'll go and give you a couple of demos around it and connects back that how it fits with the security ecosystem. So what is an AI? It's a big umbrella, which is that you are deploying or building techniques mimicking the human behavior, versus machine learning and the deep learning. They are the core components of artificial intelligence, in which machine learning is basically ability to learn without being explicitly programmed. For example, you are given an email data set. Now you want to identify whether it's a benign versus it's a vulnerable. What I meant by that is whether it's a spam email or is it a legitimate email. So that kind of extracting information from that data, it's pure machine learning. Now, if I want to do handwriting recognition, because everyone has a different handwriting patterns altogether, right? So you need to extract the patterns from the data set itself. So that's the deep learning. Now that I have explained you the core and the basics of AI, I want you to take a minute and think. Think which of these faces are the real faces or which of them are the fake faces. Please raise the hand if you think face A is the real one. Okay. Please raise the hand if you think face B is the real one. Interesting. Okay. It seems a lot of folks think face B is a real person. Okay. What about the face C? Is that a real person? Please raise your hand if you think face C is the real one. Okay, awesome. So the answer is none of these faces are real faces. These people do not exist on planet Earth. I'm not sure about the extraterrestrial planets or maybe Mars, if Musk finally gets to the Mars over there. So the important concept behind this is these are all faces generated using Gen AI technologies. That is, you are learning the patterns from existing human label data set, and then the models or the algorithms are synthesizing the brand new data instances from those learned patterns. Okay? But there is a common framework, or I would say a cell behind all these deep neural networks, which is, I'll show in the next slide. Yeah. So this is a basic framework of a neural network. That given an input data set, there is a weight, sum, biases, and activation function. Think of weight, sum, biases, and activation function, these layers, as a black box, and that's what we are going to decode in this entire presentation. and then it gives you an output. Output could be anything that you are actually working for your use case. Could be an image recognition, could be speech recognition, anything. So this is a basic framework of deep neural network. And then in 2016 or 2017 around, there is a paper released by Google which said attention is all you need, which basically gives a new architecture altogether. That's a transformer architecture. And you must have seen in the GPT-3 or other GPT 4.5 and all these models, they are using the technique behind all of them is transformer. What happens is you are having a stack of encoder, decoder, and then there is an input being fed to it. It will process the information and then it gives you the response. As you can see here, the GPT-3. So input I'm asking is, can you recite the first law of robotics, and then it will give you an output based upon that, right? And the technique which is working behind it, or the architecture which is working behind it, is the transformer, which basically gets a lot of scale in a sense that a lot of billions of data set has billions of parameters, and then it gives you the response based upon a certain context length. Okay. Similarly, LLMs can be used for various purposes. For example, you can use for reasoning purposes, could be using for vulnerability detection, and I'll give you some examples in our presentation as well, that how using LLMs we can identify the vulnerabilities in the code in itself. It can also be used for doing security analysis or for code generation. The example that I've shown in this presentation or in this slide right now is the garden was full of beautiful, let's say there is a dash towards the end. So butterflies is one such component. It could be flowers or it could be something else, right? That is the predicted probability given by the LLM, that this is the word which suits the best, and that's what could be the next word prediction or a token prediction. So, okay, the first use case that we will be working on is identifying the quality of a plugin, the WordPress plugin. Now, this dataset exists on the Kaggle and it's an open source dataset. For our purposes, I have shown just the first few samples and the rows of that dataset, that how it looks like. So, this dataset has a slug, tag, version, and so on and so forth, and also the active installations, that how many people have installed that particular plugin, and also when it was downloaded, like how many folks have actually downloaded. There is also like a ratings, how many people have rated this particular plugin. Okay, so this also shows the requires, so that's a version of the WordPress. So this entire data set is already freely available. I'll share the link towards the end as well so that you can understand more analysis around it. The key part for doing any kind or building any machine learning pipeline is to first understand data, do some hypothesis testing, analyze what kind of patterns or information that data contains, and then build a use case on top of it. So that's what I'm following here. I'm first trying to identify what are the popular plugins, or what is the EDA after doing the exploratory data analysis. So I found Elementor and Contact Form, these are the popular plugins in that data set itself. So that helps me to build a use case and also to test around my hypothesis. So the use case that I'm going to build is, can we identify the plugin quality using open source large language models using Microsoft Phi 2 model? You are free to use Llama models, you are free to use GPT-2 models as well, or there are so many other models like the Tiny Llama is also there. But I'm specifically using Phi 2. I can use definitely other models, depends upon the quality or how you want to tweak that model. So this is what my use case is, the first use case. First, I'll explain diagrammatically how I have built this architecture or the solution, and then I'll go on the code snippets as well as the demo, that what is the final response came out of this model. So what I did, first is I have this plugin dataset. It is pre-processed, I did some pre-processing. Then I calculated the risk matrix. The risk matrix is done through a three-way process. First is whether the plugin was updated in the latest phase versus not, what is the installation count, and you will see 40%, 30%, 30%, which is the weighted summation after calculating the risk score. Again, it's purely hypothesis basis, pure heuristics, but the analysis like installation count, version risk, and what is the update risk, these are all coming from the data itself. So version compatibility gap from what is required versus what is tested upon. So that's another component in order to identify the risk metric. And then after I've calculated the weighted risk, I'm assigning the categories, whether it's from 1 to 5, whether it's a low risk, I mean whatever the score it came out, if it is less than 1.5, then it implies it's a low risk. If it is greater, it relies to a certain range altogether. And then that information is passed to the Phi2 LLM, large language model. It will do some analysis, which will give you what are the vulnerability concerns, what are the recommendations, and what are the assessment. And then it will generate a very nicely crafted report, which could be understandable by the layman as well. Okay, so how I set up the Phi2 large language model. This is very pretty basic. You can use Hugging Face and all of these, marketplace in order to get that model. So I'm using a specific model, what I've defined over there, Microsoft Phi2. It's an open source model released by the Microsoft. Using a device, you can also use the GPUs if you have the CUDA and all of that. I'm using like a auto. And then there is also like a 4-bit true, and of course those are certain parameters that you always have to put in while you are training the models or fine-tuning the models based on your use case. And then there is a specific prompt I'm feeding into that LLM. The prompt says you need to calculate the risk score, or the risk metrics are the risk score, which implies from the data itself and the day since it has been last updated. That's another. What is the WordPress version it should be required and on which it has been tested on. So the use case that we are working on is to understand the quality of a plugin, right? Because we have to update our website, we need to understand which plugin suits the best for our website. So this analysis will really help us in fine-tuning / and helps in updating whatever your website needs to be updated with respect to a plugin. And then I'm asking what are, on the basis of those metrics, provide me the security risk assessment and specific vulnerability concerns around it. So this prompt has been fed. I'm maintaining a constant temperature within the large language model, not changing around it. And then I'm asking, then you can see the response it has given. So this is one small plugin. There are multiple plugins because analysis has given like a lot of plugins. So you can see, okay, this risk score is 3.8 on a 5 scale. So definitely it shows like a critical risk score. And then the day since it's last updated seems like a couple of years. So it needs to be updated, right? And then it gives you certain other metrics. I'll show that too. So you can see after analysis, it says that the plugin does not have the input validation, gives you the security issues which are present in that plugin, right? And then it does not provide the protection against the CSRF attacks. It also shows that. And then it gives you the recommended solution, how you can fix those security issues within your WordPress plugins. Enable SSL, TLS, or just update the plugin and just reach out to the administrators, because these are security issues that are present, and if they can fix, the developer or the maintainer of that plugin can fix that. So this is one example. Okay, now I want to build on top of it. I want the model to give me an explainable response. What I meant by explainable response, or maybe I can show the report also. Let me go show the report. So you can see here, is it visible at the back? Okay. If not, I can improve the font as well. So you can see after doing the analysis, this is the entire report being generated for various plugins within that data itself. You can see the analysis being done, right? For a different plugin name, these are the metrics and these are the scores. For a different plugin, like it shows risk categories are critical. Why it is critical? Because of this analysis and this risk metrics that it has shown here, right? So this is a very nicely crafted report that will be generated. I'll push all my code as well as the slides on the GitHub so that you can access after the end of the presentation as well. Okay, now coming back to the main core of my talk, which is building explainable. So what I meant by explainable is understanding what is happening behind these black boxes, why they are giving the response to what they are giving the response. So understanding the why is really important to decode these black box models. Okay. This use case is different from what we did previously we did the quality of the plugin. Now in this use case we are simply asking whether you recommend that we should use this plugin versus less suitable or not recommended based upon the features and the data given in that plugin dataset. And Lime is a package, which is a package in the Python itself. So you can use Lime, SHAP, or any other more, any of those explainable AI, responsible AI packages, just to understand and decode which features are contributing to a model's input or the response. So over here, first I'll give a very basic example. Then I'll show the code as well, because I want people to understand what is happening here. So you can see, so basically consider it's a sentiment analysis, right? What I meant by sentiment analysis is I'm thankful to the organizers for giving me the opportunity to speak here. It shows my positive sentiment. And if I say, I don't like pineapple on a pizza, why my brother loves it. So that's a negative sentiment, right? So anyway, so coming back to this question. Now here, given a test response or a text data, you need to identify which plugin is recommended and why it is recommended. So you can see the orange as well as the blue, and the orange shows the positive words which are contributing to the model's input and giving the response around it, and you can see the probabilities as well. There is also like a word by word probability, which implies combining all the word probabilities, it will give you a response that okay, with 90% confidence I'm saying this plugin should be installed or this is highly recommended. So you can see this is how the Lime's response is going to be. The words which are contributing, for example slow, it is contributing to a negative sentiment, but it is contributing to a negative sentiment. Plugin great and this with and all of these, you can see the the x-axis is kind of a probability distribution of those words. So the positive words are the green in color and the red ones are the negative. So these are the plugins that you need to install. So this is how I have tried to build the explainable solution for a specific use case around it. Okay, so how I did. So again, the data set was given, you have to do, so this data set was text data set, right? You can't feed the text data set into the model. It has to be converted into the tokens. So that's why I've used TF-IDF vectorizer in order to create a vector or tokens around it. And then I'm asking, okay, which are the features which are contributing to the plugin's response, and what are the pros and cons? Which quality of the plugin would you recommend for me? And then it will give you again the response which I showed in the previous slide. Okay, so this is one of my really, I would say I love this actually, MCP, which is a model context protocol. So I'll explain what I'm doing in here. So the last example that I want to show in this presentation is given code. Since WordPress plugins, a lot of PHP code is there. There are a lot of vulnerabilities which are identified on those code versions, right? Can we identify which vulnerability that code or a plugin has and why it has? So the why is being answered through the explainability and which is being answered through the AI itself. So what I'm trying to do in here is MCP is, you are in on the top, you can see on the right side, you can see the code. You are passing the code input. You can pass the file or the entire plugin also, and then it will give you a response which shows, okay, this file or this particular code snippet has this specific vulnerability and why it has it. So the why is also like a description around it, and then what is the fix? How can we fix it? So I'll show this one example, and I'll also go through the code too. So this is how the response will look like. So okay, so I'm using this fast MCP released by Anthropic AI What I'm trying to do is, I'm also using OpenAI, which is the calls which is happening behind the scenes. So the prompt that I'm providing is list all the vulnerabilities identified in a specific plugin, what type of vulnerability it is, what is the severity level, and could you provide the brief description along with the suggested fix. So that's how I'm doing, and also I've given him a few short prompting in a sense that, okay, this is how the format of the response should look like. I'm using GPT-4 Omni. You can use any other model as well. And when I run this one, just a second, sorry. Or let's, okay. So what I'm trying to do right now here is already there is an input. Let's use some other input. Let's say the SQL engine. So PathStack has this a lot of academy or the learning resources. Let me copy this one vulnerable code example. Since we already know it's a SQL injection, let's see whether the model is able to identify it versus not. So when I run this tool, let's see. Yeah, so it gives, the response around it. Okay, this is the highest severity, this is the type of vulnerability, is a SQL injection, and then it shows, you need to use specific, what is the fix around it, and towards the end it gives you the summary also, that this code has multiple vulnerabilities primarily related to the SQL injection and improper input validation, so you need to fix around it. So using MCP, all these AI tools altogether will help in understanding what the code base that we are working with and what are the security issues behind it. So I will release this code as well, and people can also check in around. So let me take one more example from here. Let's see if there is any vulnerable code in around, or maybe like PHP object detection. That's easy. Yeah. So this is a vulnerable code given here, and so if I hit on run tool, let's see if it gives. Okay, sure. So it gives, the response is improper input validation. There is also like information disclosure around it. So again, towards the end, it does imply that this code snippet has multiple vulnerabilities corresponding to which type of vulnerability it is. Again, that depends upon the security engineer to understand. There is also like a human in the loop involvement around it. Okay, so coming back to my slides, where are those? The next one. Since I've explained all the flowery picture, beautiful aspects of using LLMs, there are a bunch of challenges around it. The first challenge that I want to talk about is, before I talk about the challenges, I want you to answer me this question, please. Because I'm not from Malaysia, so I don't know Malaysian language, but I need your help. What do you think the response of this model, the model that I've provided this prompt is going to be, A or a B? Please raise your hand if you think A is the answer. I'm asking, what do you think LLM is going to give a response based upon the prompt? Please raise your hand if you think A is the answer. Okay. Please raise your hand if you think B is the answer. Yes, that's what we think, right? But what the model thinks is very different from us. Model gives me this is the response. And this is a Mistral 7 billion model again, right? So, okay, coming back to important aspects. We use Claude, we use ChatGPT a lot, right? It does hallucinate, it gives you multiple responses, it gives you the responses which are not vetted through human engineers. So AI is definitely not going to take our jobs. It's our responsibility to understand what AI is giving the response. You can see the Claude or the ChatGPT is just laughing at us, right? As a developer, it's laughing at me. How can you believe in my response? So the underlying fact is LLMs are prone to hallucinate. They are prone to give false positives or a lot of false responses or making up information by themselves, which doesn't even make sense. So you need to be aware about when you are using all these LLMs. And the next is, there is a limited, I would say, context window. You can't parse a lot of internet information at once. Model will hallucinate, will say, okay, timeout error. Like this is beyond my control. I can't help it. So as you can see, Gemini, right? So this is one of the Gemma 9 billion parameter model, which has a limitation on the context window. You can't pass more than 8,000 tokens around it. So you need to be aware about the context length issue, which is already existing. And then towards the end, okay, so now I want to leave you with a couple of conclusions in a sense. LLMs are definitely helpful for our use cases for building an automation around it to reduce a lot of manual jobs around it, but we need to be sure about what kind of context the LLMs are bringing in, right? And we need to also understand, can we combine these LLMs with the traditional AI technologies to make secure, secure ecosystem around the WordPress? And at the same time, LLMs are definitely not going to replace any of our jobs, but definitely they are going to help and automate a lot of our manual intervention which is needed, and therefore it's our responsibility to use them in a healthy way. And that's it for my talk. But there is a scan code. You can get the access of the code if you scan this one. And please sign up for this MVDP program at PathStack. You can submit the reports, get the bounties around it, and welcome to the PathStack community around it as well. Thank you so much. Happy to take any questions.